Hello everyone, hello students, hello graduates, so everyone welcome to my channel related to math and physics. Alright, so I came back with a problem 3 in connected particles topic. I just remind you that this is A-level stuff, it's mechanics for first year of education, and just quick review what we've done so far. So actually the formulas and approach of the model of the kinetic particles were explained for you guys. There are plenty of examples if you're not sure how to apply this concept to the problems. Here on this small page you can find everything you need. Alright, if you're not sure, just watch the video again. And we've covered problem 1, that was EP level, and also challenge problem, so solution you can see here. Again, if you're not sure how this works, for example, for 3 bodies connected to each other, and one, for example, is hanging on the pulley, where you see the string that pass over the pulley, again, just rewatch that. And we arrive to problem 3. So that's going to be the final problem within this set, and this is sort of EP level. So actually, if you feel good with connected particles topic, so you can skip this video and move to, I don't know, maybe just other stuff in mechanics. So there are lots of videos there. So if you feel some difficulties, again, try to grab your pen and notes, try to do by round as always, and let's have a look what we can do here. So here's problem 3 again. It's EP level, but it consists of like several questions, so of different difficulties actually. But if you start thinking about this problem in terms of drawing the picture, you're on the right way, trust me. Alright, so let's have a look. And for first 2 questions, I think we need to draw something. So first of all, as you can see, the model of kinetic particles can be applicable here. First of all, because there are 2 bodies, actually the trailer and the car, so let the car a little bit smaller because the mass is smaller than the mass of the trailer, so that's why I will mark up as small m for the mass of the car. Okay, it's 3,100 kgs, and capital M for the trailer. So they connected with invisible, basically. It's sort of like unstretchable string, inextensible lines. So that's why we definitely can apply the model of kinetic particles. So what it means, one more time, just recap quick. So it's basically the idea where 2 particles connected with a string can be considered as one single object because each the distance between them is not changing, so each object is moving with the same acceleration, with the same velocity at a given moment of time, and they're moving along the straight line. Okay, so that's an idea. And inextensibility allows us to judge as we described before. Okay, so what we need to do, of course, we need to draw up all the forces that act on it. And as you can see here, there is a driving force that exerts, the engine exerts, and that means it's to the right. So it's going to be a driving force here, Fd. So there is also a resistant force which acts on each basically object here. Let it be F1 for the small, for the car, and here is going to be F2 against the motion for the trailer. There is also tension force. So this part, the trailer actually, the trailer pulls a little bit the car, so that's why the tension force obviously directed in that way. This is for the car, this is for the car, and for the trailer, the tension force still, like, it's the same. Of course it's the same because we do have an very light string, so that's why if we apply the second Newton's law for the string, we actually can prove that both tension force are the same. Okay, because there is no actually the right side the resultant force. If you're not sure, again, rewatch the video where I explain those basics, why we can consider like we described. Okay, so what we have also, there is nothing to do except for just set up the second Newton's law. Okay, so let's set up the second Newton's law. I'm not gonna just input directional axis, so but by default it's going to be directed to the right, and everything we need to project on that direction axis. Okay, it's x-axis in our case. We also know that acceleration of the whole system is to the right, so that's why we are also given the value, so we know that. Okay, and we also given the ratio of force F1 and F2, 2 to 3, that's resistant force. Basically, if you want, I can mark up as here resistances. Okay, so force of resistance that acts on each part of the connected particles. All right, so what I'm gonna do, I can actually consider the whole object as a single one, but for those who are not sure why you can do that, I can separate actually, I will complete the two equations for the car and for the trailer. Why? Because in the next question we need to find the tension, so that's why I think it would be valuable anyway. So for the car, what I will have the driving force, which is 80 kilonewtons. Then I take away all other force, F1, and the tension, and the result is going to be m times a according to the second Newton's law. Okay, so for the trailer, what do we have? We have only tension force, so actually it's pulled up by the car, and that's the sort of like driving force that makes this trailer moving. All right, so that's why it's tension minus only F2. That's the only force against the motion, and that's going to be m times a. Okay, different m. So this is the system of equations. And so what we can do, we need to get rid of actually tension, so that's why we add them up, and we'll get driving force minus F1 minus F2 is going to be equal to, so I'll factorize A, and on the right side I will have the total mass. So actually what you can see here, this equation allows us, we could derive this equation from the connected model as if we consider two objects as the single one. Okay, so because we neglect any internal forces like tension force in our case and any other force that acts within the system. Okay, in our case there are only tension force, so we basically kill them and we don't consider it, because we need to consider only external force with which actually our connected particles interact to. Okay, so this is the straight outcome. All right, so what we can do, we need to find F1 and F2 separately. That's the first question. So what we're gonna do, we can express from the ratio F1 is going to be 2/3 of F2. So what we can do, we can plug into this equation, and we can also plug all other values, but I'll just derive the general formula because there are different types of students. One of them trying to calculate immediately and plug all the values. Yes, that's the easiest way, but for more complicated problems and for the skills of formula derivation is actually kind of worse thing than for those students who actually can get the final formula. Okay, so that's why I'll show you how to get the general formula for F1 and F2, and then we just plug the values. All right, so we plug instead of F1 this expression in terms of F2, and finally we'll get driving force minus A times m plus m is going to be equal to, and if we plug that, we'll get 2/3f. So actually on the left side, after expressing F1 through F2, we'll get minus 2/3 F2 and minus F2. If we combine them, we'll get negative 5/3 F2. But once we transfer to the right side, we'll get this positive, so that's why it's going to be just simply 5/3 F2 here. But I don't want to keep that, and that's why I'll just erase, and I'll express, as the fraction. We've got 5 over 3, so it would be inversely 3 over 5 of this whole expression. And that's going to be the resultant value for f2. Okay, so we've got that. This is f2. Of course, I'm not going to express f1 in this like awful way, and I just simply calculate f2. Let's plug the values, so we'll get 3 over 5, so we'll get 87 minus acceleration 5 times the total mass, which is simply the result of that. So I'll write 300 plus 4950. Okay, that's going to be the final expression in terms of values. And once we do, we'll calculate that. I hope my calculator is okay, calculates correctly. So 23,850 newtons. Okay, this is the expression for F2. All right, so it's right time to say that F1 is going to be equal to 2/3, right? 2/3 of F2, and if we calculate, we'll get 15 and 900, and that's going to be F1. Of course, it should be lower because it's part of F2. Okay, so there are two forces of resistance that we are asking in part A. So this is the answer to part A. So answer to A. All right, and in B, we need to find the tension in tow bar. So actually, we can use the second equation from here. And to answer B part, we just simply need to express T. So tension is going to be equal to F2 plus capital MA. So that's the final formula for that. I also probably put this as the formula as well, and that's for tension. So using again the second equation, so we can calculate tension is simply F2 2385 plus M capital MA. So it's going to be equal to 48 and 600. Okay, so that's the tension force that we ask in question B. All right, so what's happening in C? So one more time, make sure you got everything the same. If not, just write the comments why, and I'll try to explain why actually you didn't get. Probably I was mistaken, so who knows, right? There's the human factor always takes place. All right, so let's have a look at C. When the car reached a speed of 10 meters per second, the tow bar was broken. Okay, so that means the car is moving faster, right? Because the driver, the car didn't apply the brakes all the way along, so it just actually the trailer was left by its own. Okay, and the driving force for the car stays the same, so it means he didn't apply any like changes on its motion, so that's why it just moved far away. Okay, so what about because actually it has lack of tension force, actually he should feel that it accelerates. Okay, the driver should feel this as if here actually in reality he is accelerating because there is no any tension force up to the tow bar was broken. What about the trailer? The picture for the trailer is going to be as the following. So right now it just all alone, so the tow bar, even if it's tow bar left with the trailer, it doesn't matter because it's light, means it's weightless. Okay, so we don't take into account its mass, so that's why the trailer with the capital M left, and now the starting speed is 10 meter per second. So what it means its initial speed and initial velocity to the right when the trailer keeps moving by its own without any tension force applied. So now we understand because all forces of the resistance remain unchanged, so it means it's still under influence or under impact of the force of resistance. In our case, it's going to be F2. So we've calculated F2 as 48 and 600 newtons right now. And that's it. So there are no other forces. There are no driving force. It's only force that acts on it. So there are two ways how to solve. I would use the laws of physics. So that's going to be a kind of shortcut. I'll show you two ways. So using the physics law, so using energy conservation. So you ask me what's the conservation here if the resistance force X, but it doesn't matter. So energy is changing, of course. So change in the mechanical energy of this object is going to be equal to the work done of any other force. In our case, the work done by the force of the F2. So in other words, work done is going to be the work done by the force of resistance. So now it's slowing down, and acceleration, of course, according to second Newton's law, is directed to the left, okay? But because we asked about the distance covered, how can it help? We can express the work done through the force times the distance, okay? Times the distance. And it's going to be negative. Why? Because actually displacement is to the right. So actually I need to make a little amendments. Of course, d is going to be equal to the distance, but in reality it should be displacement. Actually, it's scalar product of the force and displacement. But according to what we see here, displacement is to the right, while the force is to the left. So that means they should have negative sign, okay? What about the change in energy? So because there is no any change in height, so it's still moving on the horizontal road, change in energy is going to be equal to change in kinetic energy. And what it means, because finally stopped, so the final kinetic energy is 0. So kinetic energy 2 minus kinetic energy 1, and this is by definition, but kinetic energy 2, so it's going to be equal to 0, and we'll be left with minus initial kinetic energy, which is mu squared, in our case capital M, because that's the trailer, mu squared over 2. And if we equate that to the right side, we'll get mu squared over 2 is going to be equal to F2D. And now you understand why two signs, we actually need them, because later on they will be cancelled and everything is correct. From where we can express distance. So distance from here is going to be equal mu squared over 2 F2. So you understand that I actually put more efforts, and that's why it took a bit longer, because I explained how to apply this in details, okay? Now, if you want, you can just plug the values and we can calculate, okay? We can calculate, so distance is going to be equal, so plug all the parameters. So mass, in our case, is 44950, and we just plug that, calculate, and what I've got 1038, about somewhere around 10.38 meters, okay? That's how far it will move. Okay, until the stop. How to use the second way, through basically kinematic approach, or maybe you apply also second Newton's law. So because you understand, acceleration is no longer be equal to 5, right, meter per second squared. Why? Because this new acceleration, and this is acceleration of the trailer itself. So obviously it should be different. So for those who were trying to apply, for example, simple formula d equals to u squared over 2a and plug a equals 5, were incorrect in this approach, because acceleration is a new one. However, you can use this formula, right, because final speed is 0, so finally d is going to be equal to u squared over 2a. Everything is positive, don't worry about that. So which acceleration we need to use? Of course, we need to figure out, and we can set up also second Newton's law, where F2 is the only force, be equal to m times a. And if you plug acceleration being equal to f2 over capital M into the formula, you'll get what you actually should get. So u squared over 2f2 and times m. Actually, as you can see, the formula is still the same as you actually expected to have. But this takes into account a bit different approach. So actually, this also works, but for me, it's easier to apply some knowledge from physics. And I also encourage you guys who also study physics, apply this way. All right, so hope you got it. So we covered the whole set of questions for this set related to kinetic particles. I hope that it was really helpful for you guys, and see you in the next episode. Peace out.